everyone, welcome back to the video lecture series of learning theory of automata and formal languages. We are into unit number 1 and we are currently learning this is lecture number 4. So, my name is Binayak Parashar. I am working as an assistant professor in the Department of Computer Science and Engineering at J. Kumar Garg Engineering College. So, I will be continuing with the particular topic of finite automata, and in the previous 3 lectures we have continued with the concept of basics of automata, finite automata and the construction of a DFA. So, in the previous video lecture we have seen the construction and the designing phase of a DFA. So, in this video lecture I will be continuing with lecture number 4 only, the construction and design of a DFA with few more examples. Okay. So, let us check what is the topic for today's agenda is the topic is deterministic finite automata only. We will try to look the concept of acceptability of a string and language. Okay. So, it is just a small topic, but yes, we along with this we will look into some of the examples of designing a DFA, because at least you need to carry forward more than 30 examples in order to accomplish the construction or designing of a DFA and NFA. If you understand all these 30 topics, then it will be easy for you to design the DFA, NFA and also in the upcoming future. Okay. So, let us check it out with the first topic, that is processing of strings of by DFA. This particular topic we have seen in lecture number 2 also. So, but I will just go a little bit elaborate with this, as you have already done the designing process in the previous video. And students, if you have not gone through the previous 3 lectures, I would request you to go through the previous 3 videos, then it will be more easy to understand this particular concept. Okay. So, processing of a string by a DFA. So, it generally says, suppose here we are having n number of strings, sequence of strings, okay, it is already mentioned as an input symbols are nothing but the strings only, and we are having some set of states for corresponding to set of these inputs, okay. And finally, for processing of the string by the DFA, we need the 2 concept acceptance and the rejections. How it happens? Suppose I am having a state q naught, I am having another state q1, I am having another state q2 and I am having one more state q, suppose d. Okay. So, these are the 4 states I am having, and processing of strings now come across with the strings. Say suppose I am having a string, say a1, a2, a3, let it be a3, okay, let it be a3. So, therefore, if I look into the particular diagram, for a1 there is a transition, for a2 there is a transition and for a3 there is a transition. Okay. Now, if I need to process this particular string a1, a2, a3 and to be accepted, I need to declare one of the state to be the final state, correct. And suppose from state q1 to qd I am having a transition, say suppose q1, this is not a q1, this will be your a1 suppose, okay. Then this means that this particular string from a1 to q1 from q1 state, again I am having a particular input symbol a1, it is going to another state, say suppose qd, from where there is no other transition going to the final state, then this particular state is said to be the dead state and it is also said to be the rejection part. So, therefore, this is the accepted part, where it is accepted is the final state, where rejected into a state where we can say that there is no transition from there to the final state. So, processing of strings by DFA is done in 2 ways, accepted and the rejected part. Okay. Coming to the next concept, these are some of the preliminary basic concepts. Okay. Language of a DFA. If I say language of a DFA, we need to accept 2 things. First of all, if we look into these 5 tuples, and this is nothing but the final state, okay, and this is nothing but the initial state. IS stands for initial state, FS stands for final state. This is just my nomenclature. Okay. Then we need to find out the transition function in this pattern, that on seeing a particular state from a particular string, it will go to a final state. Then we can say that a string W is accepted by a DFA correctly. And if I say another way, that W being a string such that from a state q on seeing W, it is going to another state, okay, and we are telling that particular string can be accepted in a different states other than the acceptance states. So, then we can state that the language L is accepted by the DFA. So, this is the two concept, a string and a language is both accepted by a DFA. How? If these two concepts follows, if these two transition function follows. So, it is already been defined that when we say that it is accepted when it reaches the final state, this is the final conclusion. In terms of language, this one, in terms of string, this one, that is it. Okay. Now, let us go with the next concept, the language and its operations. Okay. Now, before going into the operations part, first we should be clear with few points. Okay. First point is that finite languages include finite number of strings. This is very preliminary step which we have already learned in the initial concept when we will discussing about finite automata. Second point is that, however, most languages of interest are infinite, just the question that we have done in the previous video, that length is at least 2. That means, at least 2 means what? Minimum it should be 2, then it can exceed n number of times. So, it would be infinite. Then phi is an empty language. Okay. Then epsilon whole bracket curly bracket is a language, do not say that this is a string, no, it is a language for any alphabet. Okay. And this phi is not equal to this one, do not get confused. Phi means completely empty, the language is empty, no string, nothing. And epsilon means what? There is a string, but but there is a string which is having an empty, which is having a null and void case. Okay. So, do not compare this and this to be equal. Okay. So, this is a valid point. So, you can keep in or you can note it down. Let us go with the next part where we will see some of the operations for the languages like union. So, if I say L1 A B A and if I say L2 B C D, then definitely we can do a union of these two languages. Okay. Intersection means what? The common part, that means the string which belongs to a language say L1 must also belongs to a language say L2. That is as simple as that. Intersection. Complement, what is the meaning of complement? Suppose L is a language say even numbers or length equals to evens, I suppose, then L complement will be what? Just a vice versa, odd numbers, that is it. Okay. So, complement means vice versa. Okay. Next, relative complement. If we talk about relative complements, so suppose I am having a set Venn diagram, we know about Venn diagram A and B. So, if I say relative complement of A in B, then exclude this B part, then this will be the main part of relative complement, correct. Symmetric difference, if we exclude the intersection part and then summarize the union parts of both the sets, that will be your symmetric difference. If we talk about concatenation of two languages, so suppose it is represented like this, L1 complement concatenate L2. So, suppose L1 is equals to hello and L2 is equals to let me write over here, let me write this particular thing over here. If L1 is equals to hello and L2 is equals to world, okay, then L1 concatenation of L2 will be what? Hello world. Just you need to concatenate two things. Okay. Then reversal of a language. Reversal of a language means if L1 is equals to A B A, okay, then L1 to the power R means reverse, it will be A B A only. So, it is just like a concept of palindrome. Okay. So, but if I say B A B C, then it will be C B A, just reverse. Okay. So, basically these are all like a sort of explanation to you all, but you all already know about this. So, basic set operations on languages are union, intersection, complement, relative complement, symmetric difference, concatenation of two languages and reversal of a language. So, these are the basic operations being performed over a language. Based on that, you can design a particular automata. Okay. Now, we can come up with the next slide and let us continue with the examples that we are doing in the previous video. Previous video we have sum up with 5 examples. Now, I am going with the example number 6. In the example number 6, it is very easy, it is just a you need to understand the language first. The language says that design a finite automata Normally it says finite automata means normally you can take it of a DFA concept, okay, that accepts strings containing exactly 1 over 0 and 1, exactly 1, not more than 1, not less than not less than 1, exactly 1, okay, that accepts strings containing exactly 1 over alphabet 0 and 1. So, you need to concentrate now, first you need to analyze this particular language. So, if I say this language, okay, it says that design a finite that accepts strings containing exactly 1 over 0 and 1. So, exactly 1 means what? I need to concentrate on 0 and 1 part, and I need to check that 1 should be exactly 1 time. So, that means if I say like this, that will this be accepted? No, this will not be accepted because 1 is not present, right. So, you need to concentrate now and you need to find out few of the strings. Say suppose if I say 0 1, it is accepting, 0 1 1 not accepting. If I say 1 0 1 not accepting because 2 ones it is coming. If I say 0 0 1, yes, it is accepting. If I say 1 0 0, yes, it is accepting. Like this you need to analyze the strings. Okay. So, this is one part of a assignment for you can think of it, you can look into the particular language. I have explained to you the language, you try to design the diagram. Okay. Let us go with the second example, example number 7. We will try to design few of the examples, and few of the examples you try on your own to make it a habit of understanding the language and to fulfill the diagram. Example number 7 says that multiple of 3 over A and B. So, I need to concentrate both the input alphabets, I cannot left over any of the input alphabets, clear. It says that multiples of 3, okay, multiples of 3 means what? The language must comprises of 3 length, 6th length, 9th length, okay, then 12 and 15, and it will keep on going. So, definitely it is an infinite language, it is an infinite language, correct. Now, if I have to find out 3 strings, so this will resembles what? A, it may be B, it may be A, it may be B, it may be B, it may be A. So, like this it will comprise of 3. If I say 6, then A, B. Okay. So, it will keep on going. Let us first focus this particular part, automatically you will be able to analyze the remaining parts. How? Let me show it to you. Let me take first of all for 3, length equals to 3. This defines the multiples also. Okay. So, if I say initial state as q naught, one more state say suppose q 1 and one more state say suppose q 2, okay, and let me take one more state as suppose q 3, okay, q 3. So, these are the 4 states I have taken. First string will be 3 times A. So, 1 transition for A, 1 transition for A, 1 transition for A. Then I have to make this as a final state. Now, let me know that whether multiples of 3 in terms of A, is it happening? Yes, it is happening. A is happening. If I want to continue with multiple of 6 times, then 6 times if I have to continue, what I have to do? See, do not include few more states, try to summarize, try to optimize the states. Okay. How do we optimize the states? We can use the concept of backtracking. We can use the concept of backtracking. How? See, from 1, 2, 3, I can go back to the second state. Sorry, I can go back to the second state and let it be single A transition. Then what it will be? See, 1, 2, 3, 4, 5, 6, then 7, 8, 9, then 10, 11, 12. See, the flow is keep on going. The flow is keep on going, correct. Now, similarly, if I want to check for B transition, just put it comma B, my work is done. So, this is how you have created multiples of 3. Now, once the language is satisfied, as I have told you in the previous video also, you need to now focus what? You need to now focus that whether the restrictions over DFA is satisfied or not. Let me check Q naught, both the inputs are coming out, Q 1 both the inputs are coming out, Q 2 both the inputs, Q 3 both the inputs. So, my final diagram for multiples of 3 over the input alphabets A and B are done. Next, let us go with example number 8. Example number 8 will be a very simple one. So, I have given the question as that which starts with 1 that starts with 1 and ends with 0. So, that means the initial language initial string will be what 1 0, correct. That means starts with 1 and ends with 0, correct. Now, in between that there is no restrictions, it can be a combination of 1 and 0 can anytime, right. So, that means what I have to first fulfill, first I have to fulfill this particular string. What I have to do, I have to take a state, say suppose q 0, take a transition 1, q 2, q 1, then 0, then make it a final state. So, now if you look into this particular diagram, can I say that 1 0 will be accepted? Yes. And can this particular concept can be interpreted in this way, that starting with 1 and ending with 0? Yes. Now, I have to check that in between this there is no restriction, I can take n number of things. So, one more concept, one more logic might be coming in your brain, that whether the language, whether the diagram will be similar to all of us. Yes, some or the other it will be similar, some or the other it will be different. It depends on the logic, or it depends on the way how you are interpreting the particular things. Okay. Some may use one more state. Just if you look into the previous example, I haven't used one more state. Okay. I have directly did the backtracking process. So, some may use one or two more states and then process out. So, that will be a lengthier ones, but the diagrams will be different. Okay. So, if you can practice these 30 topics which I will be mentioning in the next video, then it will be easy for you. Okay. Now, look into this concept, 1 starting with 1 and ending with 0, it is done. Now, in between that it can be anything. So, let us first check that whether DFA restrictions are overcoming or not. From state q 0, if I take a self loop of 0, will it be accepted? No, it will not be accepted. Why? Because we cannot start with 0, it should always starts with 1. So, in that scenario what I have to use? I have to use a date state for this. I have to use a date state for this. Okay. So, if I have to use a date state, then q 0 state is been done. I have to now go with q 1. Q 1, from q 1 only 0 transition is going on, 1 transition is not going out. So, can I take a self loop over here? Yes, I can take a self loop. So, like this you need to analyze. So, therefore, the final diagram for this will be like this. Okay. Here they have not taken the date state because it is said as design of a finite automata. Okay, finite automata. So, it can be DFA, it can be NFA. But if it has been asked as DFA, then you cannot, this is not a DFA, this is an NFA. Why? Because there is no restriction part right now. If we put a DFA, then we need to take a date state, we are bound to take a date state for 0 transition and take a self loop over here 0 and 1. For state q 0, q 1 c, for state q 1, 1 I have taken a self loop and 0 transition, it is perfectly fine. Q 2 I have taken a backtrack, there is no worry. So, this is a perfect DFA, but if I do not take this particular part, then it will be an NFA. Okay. Let us go with the next question. Next question also even number of zeros followed by single one. So, you can think of it even number of zeros. So, 2 zeros then followed by 1, then 4 zeros followed by 1. So, always 1 will be a single. Okay. So, that means the diagram will look like this. Okay, let me erase the part. The diagram will look like this one. Okay, you can think of it, you can logically think of it, you can try this one. Now, let us go with the next diagram question. The question says that where the string starts with AA, it is a very simple 2 A's, correct. So, what we will do? First I will take a initial state, another state, right. Why? Because 2 A's means 3 states. Okay, means you can also analyze in this way that we need 2 strings, 2 A's, that means I need an initial state, one more state and one more state, correct. So, therefore, the transition will be looking like this A and A. So, will it be accepted 2 A's? Till now not, but I have to take a self loop over here because it says that starts with AA, right, and after that starts with AA. After that it can have any possible combinations of A and B, correct. So, what that is why I have taken a self loop over C, okay, but C I have to make as a final state. I have not made this here. So, this will be a final state, then only it will be accepted, right. So, A and starting with A followed by any possible combinations of A and B. So, is it a DFA? Right now not, it is not a DFA. What I have to do? I have to take a self loop over here, I have to take a date state over here for satisfying state A and state B. Now, look into the diagram. From state A is coming out, B is also coming out. From state B, A is also coming out, B is also coming out. From state C, both A and B are coming out. So, is this a DFA? Till now it is okay, but this date state is not having any transition. So, I have to make a self loop over here also. Got it? Now, this is a perfect DFA. Okay? So, if we avoid the restrictions, that will be an NFA, as simple as that. You can go with example number 11. Example number 11 says that where the string ends with BB. Now, this is not a starting with AA, it ends with BB. So, that means the restriction will be at the ending part, not at the starting part. Starting part can be a you can put a self loop over there. Okay. So, what will be the diagram? The diagram looks like this. Okay, I have taken 4 states. From state A, I have taken B. From state B, I have taken again another transition for B. So, BB it has been, then definitely C should be the ending state. So, here also I have not mentioned. So, C will be the final state, right. And in C, can I take a self loop for B? I can take, because they are telling that ending with BB, correct. So, 2 B's should be there, it is happening. But for A self loop, can I take? No, I cannot take, that is why I have to take the help of a date state. Okay. So, for A I have to take a date state help, and for state A there is no restriction in the initial part, because ending with BB it is telling initial part does not have any issue. So, what I can do? I can take a self loop of A, but I cannot take a self loop of B. Why? Because already there is a transition, and now we are concentrating only DFA, not NFA. If it would have been NFA, then you can put as A comma B, there is no problem. I will discuss that in the NFA part, but for the time being it is a DFA. So, therefore, I cannot have a B transition over here, I cannot take a B transition over here, this is not possible, because B transition is already there. Got it? Therefore, finally, what I can do, this will not be happening, because B transition is already there. So, this particular line will not be happening, this date state is only used for the particular state C. Okay. And here we have to take a self loop, and finally, this state B I can backtrack for A transition, because if I backtrack the A transition, then possible number of strings will increase. Say suppose the string is A, which these 3 A's will be coming from this self loop, and then followed by B, and again A comes, then I need to take a B, I need to take a self loop, backtrack, correct. Either I can put a self loop over here, if I take a self loop over here, then these 2 B's will have an interaction over here, got it. So, therefore, we can backtrack over, got it. Therefore, the final diagram will be looking like this. Now, let us go with example number 12, exactly 4 ones in every string, exactly 4 ones. So, you cannot exceed. So, directly you just go with the restriction part, exactly 4 ones. Is it 4 1? No. So, I cannot make this as a date state. Oh, sorry, I cannot make this as a final point. Okay, and then I have to take one more transition, and this will be your final state. Exactly 4 ones, exactly 4 ones. Now, they are not taking that exactly 4 ones it is telling in every string, but they are not saying that these 4 ones are consecutive, it should be in together. No, they are not telling, they are saying that exactly 4 ones. So, now we need to check that where I can place zeros, because this is a DFA, I have to construct a DFA. So, I need to concentrate both the input symbols A and B. Okay, so, actually this string will be, this is not A and B, this will be 0 and 1, okay, because we are talking about ones, okay, exactly 4 ones. So, I have to now concentrate on 0. So, can I take a self loop over here? Yes, I can take, because exactly 4 ones are there, not more than this. So, can I take a self loop over every states? Yes, I can take it, correct. Now, the diagram is done, but is this a DFA? It is not a DFA. Why? this state is accepting, this state is accepting the restrictions, this is also accepting the restriction, this is also accepting the restriction, but this is accepting only for 0, but not for 1. So, they have to use a dead state for it. That is it. So, this is the final diagram for your exactly 4 ones in every string where input alphabets are 0 and 1. Clear? Now, let us go with the next concept. Okay, we are done with the 12 questions. So, if you can overall, if you can sum up the entire scenarios where what are the topics that we have covered up, 12 examples we have done, we have tried to cover up, we have tried to cover up few of the topics. Okay. What are those topics? First, length questions. Length questions means what? Length is even, length is odd, okay, length equals to 2, at least 2, at most 2. Then we have checked even and odd scenarios. Okay. Then we have checked multiples. So, multiples of 3 we have seen. So, same way divisibility by 3, both the concepts are same. Then we have seen starting and ending concept, starting with AA, ending with BB, this concept also we have seen. Then we have seen containing concept. Containing is nothing but containing is nothing but this concept, containing exactly 4 ones in every string. So, this is also another concept. So, like this, these 5 concepts we have done and total 12 questions we have done. In the next video, we will come across with NFA concept, and also we will try to sum up these DFA questions along with the NFA questions, because if you know the DFA question, then you will be 100% assured with the NFA, because NFA does not have any restrictions. Okay. So, this is all about your today's this particular video, and if you are having any query, you can pause the video, you can retract those topics, and then you have to use your logic. So, thank you for watching the video.